All right, so for this first one, this is going to be L'Hopital's rule. You always want to start a limit problem, though, by just checking, plugging in the value you're approaching. So if we try to plug in 0 here, we're going to get 0 plus sine of 0 is 0. And then down here, we're also going to get 0 minus 0. So this goes to form 0 over 0. And we knew that we were going to use L'Hopital's rule because that's, the topic that we're covering on this quiz, but you just always want to check that, just to make sure. So we're going to do the derivative of the numerator and the derivative of the denominator. So for the numerator, that'll be 4 plus derivative of sine is cosine. And then down here, this will be 3x squared minus derivative of sine again is cosine of 2x. And that one has a chain rule. So we have to chain on the derivative of 2x, which is 2. So those are your derivatives. And now we're going to plug in 0. So for the numerator, we're going to have 4 plus cosine of 0. Just let me pull out my unit circle here. Here is 0 pi on the unit circle. Cosine is the x value, so that is 1. So cosine of 0 is 1. And then down here, we're going to have 0 minus. And then again, cosine of 0 is 1, and times 2 would be 2. And you can stop there. You don't have to simplify anything down. You could just leave your answer alone. But if you did, this would be 5 over negative 2, which most people did. So I'll just finish simplifying that there. But you don't have to. You can stop here once you get to your answer. All right, and then 2 and 3, we're just find the derivative. It's implicit differentiation because your x's and y's are all jumbled up in here. So for the first term, x squared, that derivative would be 2x. And then exponential's derivative is itself, so I'm just going to copy that down. And then we have to chain on the derivative of 4y, which is 4 dy dx. And then, hey guys, what is the derivative of 25? What is that going to give me for the other side of the equation here? And good, awesome, that would be 0. Derivative of any constant is 0. A constant doesn't have a rate of change, it's not changing, so that would just be 0. So the rest of this is just algebra. We just want to get dy dx by itself, so we're really just moving stuff. We're going to subtract over the 2x. And then we're going to divide by the 4e to the 4y. And once again, you can just stop there. You don't have to simplify anything down. I'm going to because many of you did. So just if you're following along with me, if you want to reduce the 2/4 to 1/2, you can do that, but it is not necessary. You can just go ahead and stop here. All right, so for this one, derivative of 3y is 3 dy dx. And then derivative of x squared is 2x. And then derivative of tangent of y, that would be secant squared of y dy dx. Again, anytime there's a y variable, you have to chain on a dy dx. So what makes the algebra for this problem a little tougher and why it was worth more is there's 2 terms that have a dy dx in them. So we're going to have to start by getting them both on the same side. So I'm going to subtract over this term. So we'll have minus secant squared of y dy dx. And so now once we have those both on the same side, we can factor out a dy dx. So greatest common factor. If we factor that out, we're going to have 3 minus secant squared of y. And then last step, we're going to divide this to the other side. So it will be 2x over all of that. Now, if you chose to move your terms in the opposite direction, like you moved this over here and then subtracted the 2x over, you would have gotten negative 2x over secant squared of y minus 3. The whole thing would have just been reversed and there would have been a negative with it. These are mathematically equivalent. So if you did that, that's totally fine, and that answer is perfectly correct. All right, so number 4, while I'm writing out the question, let me ask you guys. This one says to write an equation. So what are the 2 things that we're going to need to find in order to write an equation? What do we need to write an equation? Good, perfect, nice. Point and slope. So we are going to need a point and a slope. Good, nice job, guys. All right, so the point of tangency is going to be at x equals -2, so that's going to go right there. And just like usual, to get the y point, you're just going to plug in x. So the x's and y's are all kind of jumbled together, but it's the same concept. You're just going to take -2, plug it in for x, and solve for y. So if we plug in -2 for x, that's going to give us y squared minus 2y minus 8 equals 0. And so we're going to factor that. We're going to get 2 answers. And I told you this when I went over it, and I also, printed it on the paper. We want y to be bigger than 0, so we're going to keep the positive answer. So we're going to get 2 choices, and we'll keep the positive one. So this is going to split -4 plus 2. And so we get y is 4, and y is -2, and we're going to get rid of the -1, and so we're going to keep the 4. So that's the point. Now to get the slope, that's going to come from the derivative. So we have to do the derivative of this. So derivative of y squared, that's going to be 2y dy dx plus, and then this is a product rule. So it will be the first function, so x, times derivative of the second, which is dy dx, plus the second, which is y, times derivative of x, which is just 1. And then we'll have plus 4 equals 0. Derivative of 0 would just be 0. Now, many of you went ahead and got dy dx by itself. That is perfectly fine. My suggestion, though, is go ahead and just plug in your x and your y values to start with. It's a lot easier to deal with numbers than it is variables. So if you rearrange this, that's totally fine. I just think it's less work if you go ahead and plug in the numbers right away. So we're going to put in -2 for x and 4 for y. So that would make this 8 dy dx minus 2 dy dx plus 4 equals 0. And so combining the like terms, this would be 6 dy dx plus 8 equals 0. And so we're going to subtract 8 and then divide by 6. And you can leave it as -8/6. That does reduce, that would be -4/3, and that is our slope. But you can certainly stop here and leave it like that. You don't have to reduce anything. And then just to write the final answer, this is the point and this is the slope. So we're just going to put that all together. It would be y minus 4 equals -4/3 x plus 2. So it was worth a lot of points because you had to do a lot of things. Here's how I awarded the points. You got a point for plugging in the -2 and then a point for solving for y. So it was 2 points to get that value of 4. And then this derivative I made worth 3 because that's where all the calculus was, and there was a lot to do there. It was a point for this, a point for the product rule, and then a point for the rest of it. Because that's, like I said, that's where all the calculus is. So it's 3 points for that derivative. It was a point for plugging in and getting your slope, and then it was a point for writing out the equation. All right, and then this last one is your one related rate question. So this is about a boy flying a kite. So it's going to be a right triangle, and the boy is down here. This is the kite string, and the kite is up in the air. So it says he is pulling in the string at a rate of 5 feet per second. So he is pulling in this string. So I need a variable for this distance. I'm just going to call it y. You may have called it something else, that's fine, it doesn't matter, but it has to be a variable, it can't be a number because it's changing. So he's pulling that in at 5 feet per second. So that's going to be our rate for y, dy dt, and it will be negative 5 feet per second. Why? Why does that need to be negative? Why would that rate need to be negative? Yeah, good. Moving down, it's decreasing. He's pulling in the string, so this amount of string is decreasing, and the balloon is moving downwards, so perfect. All right, and then let me read what else we're told here. He is standing a horizontal distance of 15 feet from the kite. So 15 feet goes there, and that's constant. He isn't running around. I could have made him be running as well. That would have made the problem a little bit more complicated, but he is holding still. So this is a constant 15 feet. And our question mark value, at what rate is the height of the kite changing? So that is, what rate is this distance changing? So I'm going to call that x. And so dx dt is my question mark. And that should be negative because he's reeling the kite in. So it's going to be getting closer to the ground. All right, now we have to pause. Everything's moving, so we have to pause at a certain moment, and it says when it is 20 feet off the ground. So that would be when this x distance is 20 feet. So at that particular moment is when we're talking about. So that's all the information from the problem. Relationship between the variables is going to be Pythagorean theorem. So it'll be x squared plus 15 squared, which would be 225, equals y squared. And then we're going to do the derivative. So this would be 2x dx dt. 225 is a constant, so that's gone. Again, the little boy is not running around, so he doesn't have a rate of change. This isn't changing. So that's going to be 0. And then equals 2y dy dt. And you don't have to cancel out the 2's, but we can divide by 2 on both sides. That'll make those dropouts. That makes it a little bit more simplified. And then we can just start plugging things in. So x is 20. And dx dt is what we're looking for. So I'm going to leave that in there. And then y, I do not have y, so we're going to have to come back to that. And dy dt is -5. So if you are missing something, you go back to this original relationship and plug in what you have. And what we have is that x is 20. So I'm going to plug in 20 for x right there. And then we'll solve for y. So 20 squared is 400 plus 225 equals y squared. So this would be 625 equals y squared. And I made it a perfect square so that it would work out nicely for you. So when you square root this, you're going to get 25. I did have some people leave it as square root of 625. That's perfectly fine. That actually made me happy because, you know, you're getting used to not worrying about it, which is a good thing. So if you left it as 625, that's totally fine as well. And then your last step is to divide over the 20. Which you can reduce if you want, but you don't have to. You can leave it exactly like that. And then the units are feet per second. And so it did come out negative like we were expecting. And again, that's because the kite is coming closer to the ground as he's reeling it in.